Okay, so I thought I'd try to provide a little bit of context here on what it is that we are actually trying to accomplish on this paper. And for some of it, it's just spatial orientation on whether some of these, you could say some of these disaccharides, if they're possible. So as you can see, we briefly talked about this one yesterday. So now with this one, when we come across these problems, is it possible for some of these to be linked together? So as an example, I'm just going to pick a couple of monosaccharides at random, and for instance, what this is saying is this is where we want the linkage to occur. Okay, remember that if it is an alpha 1,4 linkage, those what's actually occurring. Okay, oops, that's not quite right. Okay, here's the one position right there, and then on your other monosaccharide, okay, here's the 4 position right here. So then remember what happens is there's an OH here, and there's an OH there. For this to be possible, this has to be in this position, this one has to be in here. How this goes through dehydration then is that the left one gets left behind, which means all of that disappears, and then there's your hydrogen that disappears. So there's your intramolecular dehydration where H2O is stripped off of there. The only thing you have left is that oxygen. So then when that gets linked together, it occurs like so, and that would be an alpha 1,4 linkage. So then what happens if it's going to be a beta 1,4 linkage, okay, alpha meaning down, a beta 1,4 linkage then would mean will show how that happens. Here again we have an OH there, and then okay, and then that OH would have to be in that position, okay, and then wherever these are oriented around here, okay. The left one gets left behind, that gets stripped off of there along with that hydrogen. There's your intermolecular dehydration. So that OH is gone, that hydrogen is gone. Then what we have left is that. There's your oxygen that would be linking them together in a beta 1,4 linkage, okay? These are a little more general where if we're always talking about an alpha 1,4 linkage, one is always pointing down and this one's always pointing down. If it's a beta 1,4 linkage, okay, then you have this one, your first carbon here, and your fourth carbon here, it's pointing up. I point that out for this simple reason here. Okay? I wouldn't know if I would say simple, but this is why. Because in other disaccharides, like for instance on this problem, okay, that would mean, okay, there's another if possible, okay. Sucrose, okay, this is a well-known disaccharide, okay, between alpha D glucose, so we know that exists of course, and beta D fructose. Illustrate how this is formed as an alpha linkage, okay, so that means on your first carbon that linkage is going down, okay, and for glucose a beta on the second carbon. So you have to illustrate, well, where is your second carbon located on there, and that one is going up. So that's one of them examples where you have, rather than just straight up alpha 1,4 where it looks like this, or beta 1,4 where it looks like that, this is telling you it's pointed down on your first carbon, okay, and then beta on your second carbon, okay. Now, the reason that's a little tricky is because you got to remember this guy here, even though there's 6 carbons on there, it's not a 6-sided figure, okay? And the reason for that is this is an aldose sugar, and then this is a ketose sugar. And once you perhaps draw them out, it'll be a little more apparent on what it actually is we're referring to here. Okay. All right, so I'll go ahead and shut this down for just a moment. So then, like I said, we would give you a little bit of context here. I'm just making up two monosaccharides since these are next to one another. Gulose and idose. Remember, those are two that you don't have to know. So we're going to say, okay. And for gulose, it is right, right, left, right. Right, right, left, and right. Okay, so this is gulose. Then for idose, it is left, right, left, right. So left, right, left, and right. Okay, now, perhaps by this time we have a pretty good idea on how these rings are actually closed and how they actually look. Again, it's just a very quick review on how these rings actually look like. These are both aldose sugars. So then remember, okay, we'll just make these both alpha and alpha. So if possible, can this form an alpha 1,4 linkage? So what that means between these two sugars, okay, that's how it's supposed to look like, if possible. So we don't know. That's why we're saying if possible. So I'm just going to go ahead and do this right, right, left, and right. So left, right, left, right. So now we can go ahead and get rid of that, okay, because perhaps by now we're proficient, again, with drawing these ring structures then. Okay. So, and I know this is perhaps a little tough, but we're trying to navigate our way through this. So I think I might need a different color. So bear with me. I know these are tough, but as you know, maybe it's a job for magical mechanic. Ah! So, okay, I'll grab this. Oh, shoot, now you're gonna know who I am. I better put my disguise on. Oh, there we go. All right, okay. So, as we do this, we've got, okay, we can go ahead. We know how this is supposed to look. Okay, CH2OH. Okay, this was predetermined alpha, so that is down here. Okay, and then right, right, left, right. So right, right, and then left, so that's up top. And then this had already done its flip and switch. So now we've got our alpha D gulose. So now we got to do the same thing here for our alpha D idose, which means, okay, okay, and then just go around here. It's left, so that's up, okay, right, and then this one is left, okay. So now we can fill in all of these hydrogens. That's alpha D idose, so that's also down. So then as we look at this, remember this is what our linkage was supposed to be, alpha 1,4. So this is in the right spot, okay? So that can go through that dehydration. But notice this OH molecule is up instead of down. So this configuration doesn't work, okay? Well, what happens if we flip-flop those? If we pick this one up and move over here. Notice this is still in the wrong spot. So if we wanted to make this disaccharide between these two monosaccharides, it just cannot happen, okay? even that of a beta 1,4 linkage, where if this was an OH molecule here, okay, that still would not be possible because we don't have an OH molecule there to move up in connecting those two monosaccharides in that case. So this is an example that does not work. Okay, so I just want to give you perhaps an example of what it is that we're actually talking about here. So now we have a good idea of what it is that we're referring to. I just want to go through a couple of more examples because I see we're up to around about 10 minutes already. So now that we've got a little background information on, now hopefully we're proficient with that. Okay, so I'm going to go ahead and erase this. All right. We gotta have something to laugh about when we look outside, right? But yeah, we do choose to live in South Dakota. All right. I think I certainly miss the larger whiteboard that we have at school. Okay. So then, let's see here. For instance, when we're looking at this one, both of these monosaccharides, disaccharides actually exist. But what we want you to do, these are two glucose molecules, okay? These are two glucose molecules, but how is it possible to have, for this one, 2 glucose, for that one, 2 glucose, but yet we're still talking about different disaccharides. Then when you draw them out, it would be certainly more apparent. Okay. Then, okay, for this one, okay, so one of the things that we could say, maybe draw alpha D, we'll say 3 glucosamine, okay? So I'll write that down as alpha D glucosamine. Okay, and the reason it's called this is, okay, this is derived from the sugar, and an amine group means, not that it's mean and not kind to everybody else, but an amine group is talking about that guy right there, NH3. Okay, so I'll go ahead and shut this down. Oh, I said alpha D3 glucosamine. Okay. Have this content too. Don't need 3 lines. And I'll put him over there and over here. So I don't know if this has a specific number, but we just want to give you a little bit of context to this. Okay, so I can go ahead and close this down. Okay, so then we don't need this circle here. And the reason I wrote that 3 up there is it's telling you where that amine group is, okay? Because on your prior example, that amine group was up on the second one. So it's going to look very, very similar to this, okay? All right, so let's see here. That one's down. It's on the second one, okay? Then the third one, NH3, okay? So it's on the right side. Is that up or down? So it's actually down here. Okay. And then this one we have pointing up. Okay. Then this actually did its flip and switch already. So there's hydrogen, CH2OH. And then, shoot, I can't remember if it said alpha or beta here. We'll just say alpha. And write it in that manner. So that would be, oh, it says it right here. Okay, so alpha D glucosamine. So this is how that structure would look. It's very similar to the one that we had seen right here. That's on your paper. Okay, in other words, this one right here. Okay, And then, let's see here. So if possible, again, it's saying draw them to monosaccharides. So sometimes you may have to flip them to see if they can actually orient. I think there's 3 of those problems on there. 2 of them you can write. There's 1 of them that is not possible, if I remember correctly, as I was looking at that last night and this morning. So what does that leave yet? Okay. So this, we're actually referring very similarly to that prior example we did with that glucosamine. What it's saying that, okay, so the beta position means, and again, it's derived from glucose. So you're going to have this structure here, but then what it's saying is that on your second carbon, okay, it's an oxychloral, which means just those two those 2 atoms right there. So rather than having an OH group on the second carbon, you have an OCl. So we're talking about that right there. Okay. So then, let's see here. I think that might do it for a little bit of clarity. And again, okay, so notice it says mannose. It doesn't give you the orientation, but it does for ultros, okay? Because what we're saying is we wanted you to memorize these, okay? Because we know that glucose was right, left, right, right. Mannose, I believe, is left, left, right, right. And galactose is right, left, right, right. Okay, and then, okay. And then here again, what this is saying here, for a little bit of clarity, okay, is that when you draw these ring structures, the OH for this one is going to be pointing down, okay, and then this one for the 6th position is pointing up. So it must be down here somewhere, so that's coming up from the bottom, and that's where they link together, where you're removing that water or that intramolecular dehydration. Okay, so I know it's not as convenient as it is being in-person learning, but it's the best that we can do. Okay, so if we are in class tomorrow, just try to get these in by the end of the class period, and if whether end of class period tomorrow on Friday or end of the class period on Monday. Hopefully this gives us a fairly decent start to continue to move forward, and at some point we'll probably have our first, I suppose, problem quiz over the monosaccharides. Okay, so we're up to about 18 minutes, which I think is far enough for at this time. So hopefully, again, we're all staying safe, staying warm, and try to keep up with the best that you can. And again, thank you for taking the opportunity to tune into this and trying to keep moving forward in your academic career. All right, so that's all I have. We'll catch up to you next time.